The second part of our lesson here is going over the law of syllogism. So let's look at what this might mean. The law of syllogism allows you to draw a conclusion from two conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. So the conclusion of the first statement is the hypothesis of the second statement. This might seem like a minor detail, but it's very important because the law of syllogism only applies in this specific case. And so you've got to keep it in mind every time you're about to say law of syllogism, you have to check if this criteria is met. The symbolic map looks like this. We say P implies Q, Q implies R. We're bringing in a third statement. That's what the R is. Therefore, P implies R. Okay, P implies Q, Q implies R, therefore P implies R. Let's go ahead and look at some examples. And we will point out here, it does say use the law of syllogism to get a valid conclusion. If not possible, write no valid conclusion. So sometimes we will find that the law of syllogism does not apply and we can't reach a valid conclusion. So let's look at example 6. If it is Saturday, then Jake has a baseball tournament. If it is Saturday, then Jake has a baseball tournament. Let's go ahead and label just to keep things straight. So P is that it is Saturday. Jake has a baseball tournament is Q. Okay? Can you tell that's a Q? Let me rewrite it a little bit nicer. If Jake has a baseball tournament, then he will need to pack his lunch. Let's use our map to make sure that we're on the right track. We have P for it is Saturday and Q, Jake has a baseball tournament. If Jake has a baseball tournament, is this the same as Q? Jake has a baseball tournament, Jake has a baseball tournament. So this is still Q. Then he will need to pack his lunch. This is our third statement, R. So you see how I have P then Q, if P then Q, and then I have if Q then R. So in this case, I can make a valid statement. My valid statement is, if it is Saturday, then Jake will need to pack his lunch. Notice that's P and R. I have my P right here. If it is Saturday, then he will need to pack his lunch. That's R. If it is Saturday, then Jake will need to pack his lunch. Because the Q was the same statement. Okay? Let's look at C. If a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. So see if you can think it through on your own. If not, that's fine. We'll go ahead and label, but just give it a try for a moment. If a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. I'm going to go ahead and label again. This is my P. If a number is divisible by 12, then it is divisible by 6. That's my Q. If a number is divisible by 6, does that match? It is divisible by 6. A number is divisible by 6. My Q matches. Then it is divisible by 3. That's my R. So again, I have if P then Q, if Q then R. So P implies R. Here's our statement. If a number is divisible by 12, then it is divisible by 3. The statement is valid. Let's look at 8. If a quadrilateral is a square, then it is a rectangle. If a quadrilateral is a rectangle, then it has 4 right angles. Let's check for P and Q again. I encourage you to pause and try to do it on your own. If a quadrilateral is a square, that's my P. Then it is a rectangle, that's Q. If a quadrilateral is a rectangle, does it match? It is a rectangle, the quadrilateral is a rectangle, that's Q again. Then it has 4 right angles, that's R. So again, we're going to be able to do this. Write your own statement before you look at mine. Okay, I'm about to bring mine up on the screen. 3, 2, 1. If a quadrilateral is a square, then it has 4 right angles. Again, this is if P then R, because our statement was valid. Looking at number 9, if it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. That one already sounded different. Let's check it. If it is sunny this weekend, that's P. Then you will go boating. Go boating is Q. I read it, if it is sunny this weekend. Is that what I said for Q? No, that's what I said for P. So I have P repeated instead of Q. Then you will wear shorts. So that's R. Remember, it has to be P implies Q, Q implies R. In this case, what do we have? We have P implies Q, P implies R. These are not the same thing, okay? So this is invalid, so we would have to say no valid conclusion. It's possible that when it's sunny, you do wear shorts and you go boating. I mean, most likely you would go boating in shorts, right? But it's not a valid statement because the law of syllogism only tells us that if P then Q, and if Q then R, then P then R. I know that sounds like a crazy bunch of letters, but it does make sense if you slow it down and think about it. We've got 2 more examples. Number 10. Now, I'll remind you, if you've already done these a few times, give it a try on your own. Don't just follow along and copy what I say. Do the thinking yourself. If you shop at Target, then you will use your Target red card. If you do not use your Target red card, then you will not get 5% off. Okay, let's see. If you shop at Target, that's P. Then you will use your Target red card. That's Q. If you do not use your Target red card, now look at this. Does that match Q? This is not Q. This is the opposite. If you do not use your Target red card, then you will not get 5% off. And we have R, we have a different statement. You will not get 5% off, but it can, okay, remember we have P then Q, Q then R, right? That is not the same as P then Q, not Q then R. We're not having any nots in here. It has to be exactly the same. Q has to be the statement. It has to be the conclusion of the first statement to make the hypothesis of the second statement. So again, we have another situation where there is no valid conclusion. Is it possible that you will not get the 5% discount? Sure, it's possible, but we cannot make that conclusion. This is a really important skill to get into your mind because it becomes very handy as you go further into math, especially in calculus. We use a lot of theorems. You've got to be able to look at, just because something is telling you one thing doesn't mean it's ruling out everything else. In this case, number 10, we do not have a valid conclusion. That does not mean that the statement is false or true. It simply means that we don't know. We do not have the criteria met for the law of syllogism, so we don't know. That's all we can actually say here. So last one, if it snows, then school will be canceled. If school is canceled, then students will need to make up a day of school. So P, if it snows, then school will be canceled. Q is school will be canceled. If school is canceled, that matches again. School is canceled. School is canceled. School will be canceled. School is canceled. Then students will need to make up a day of school. That's R. So here we have again, P implies Q. Q implies R. That's what we needed to say that P implies R. So write your statement if you haven't done it yet, because mine is about to appear in 3, 2, 1. If it snows, then students will need to make up a day of school. Okay, hopefully you've got a good understanding of the law of syllogism. The key thing I hope I have pointed out to you is that we always have to double check that the Q is the conclusion of the first statement and the hypothesis of the second statement. That is a very important key detail to using the law of syllogism. All right.